Hi, and welcome to Module 3 of Advanced Data Journalism, doing more with R. In this section, we're going to be talking about loops. Loops is kind of a intermediate concept when it comes to programming, and the idea is instead of doing things one by one manually each time, you can create a loop that will iterate through it and make incremental changes based on the functions or the code that you want it to run. So let's start out with an object of 5 and assign it to x. And then let's start out with a y and assign it the number of 1. All right, so if we wanted to multiply x times y, or 5 times 1, we just type that out in the console and you'd get 5. But then what if you wanted to add 1 to the y, so then it becomes 2. And then you wanted to take that same code of x times y, and then you would get, instead of 5 times 1, it's 5 times 2 now, because y has increased by 1, so now you got 10. So what we're doing is, I want to take 5, and I want to multiply it by 1, 2, 3, 4, 5. All right, so this is what I'm doing, and I'm building that out. All I need to do is just add 1 to the previous version of y. So then 2 becomes 3. And then I can multiply 5 times 3 now, and so on and so forth. I'm going to do it one more time. I'm going to take it, y, and add 1 to it, then it becomes 4. Then I multiply that by 5, and it becomes 20. Now, very simple. So if I wanted to change that, it's just, you can see it's just really 2 lines of code that I'm repeating over and over again, which is x times y and y plus 1. Okay, so the way to turn that into a loop is you start out with the x once more, and this time the way that's structured is you type in 4, and then in parentheses you type in some kind of object variable, and so this time I'm going to type in y, and this could be anything. It could be I, x. Well, I already have x, so I can't use x again. So it has to be some unique kind of ID, and it doesn't have to be one letter. It could be many characters long. It's just simpler to just use one letter usually, because it's easier to track. Anyway, so you got 4, parenthesis, y, and then in, and then you set the limits, like between the first number through the last number, and then parenthesis, and then you do squiggle brackets, and then within those squiggle brackets is you put in the functions that you want to run. So to repeat what we did before, all I need to do is print y, and then do print x times y, right? So you see here it goes from 1 and then 5 and then no. So this is the way it works. It says for y in 1 through 3, y is print y, and y is going to be that first number you put in. Okay, so it's automatically 1. So y is 1, and then 5 times 1 is 5, so that's the output. And then it starts over again because it's reached the end. And then it goes, okay, because it's not at 3 yet, it's going to then move up to the next step, which is 2. So then y is 2, as you can see here. And then 5 times 2 is 10. And it's reached the end, and then it's going to loop again. And finally, it's going to hit the y is reaching the 3 now, which is at the end. So it's going to stop after this last loop, and then print 3. And then 5 times 3 is 15. That is it, essentially the loop. So you can start at any number. It doesn't have to be 1, and it can end at any number. So instead, I'm doing 11 through 15, and it's doing the same thing. I'm doing 11, print 11, and then print 55 times 11, and you get that. And then, what if I wanted to change the function right here? So then I can do print, and I am now using string C as a function. And I'm saying combine the number of 5, and then times, and then comma y, which is 11, equals, and then print out the output in math. So it's like combination of strings and math. And then you get this, 5 times 11 equals 55, and the next loop is 5 times 12, because it's 11, 12, 13, 14, 15, and you've got that. 5 times 12, 60, 5 times 13, 65, so on and so forth. So you can see here it's not just printing. I can do any type of function and put it in here. And then you can also not just cycle through numbers, but kind of the numbers that are represented in an array. So if we create a new object, call it text array, and put in Bob, Linda, Tina, and Louise as strings, all combined, what we want to do, if we want to loop through that, is first we need to figure out the end. We need to figure out how many different variables are within this array. So to do that, within an array, you just use the function length. And length function and then text array that we've created, we know that there are 4 different objects within this array. Okay, so we have that, and now we can create a loop, which is y in 1 through, and instead of 4, because we want to make this programmatic, because what happens if I want to add in more characters, right? So then I don't have to manually change it. I just change it up here, and then it'll reflect the changes down here. So then 1 length text array, which is going to be interpreted as 4, and then print y, which is 1, and then print text array, and then in square brackets, y. So it's going to pull out, so it's going to say like the y is 1, and the first object in text array is Bob, and then goes to the next loop. Then y is going to be 2 now in the second loop, and it's going to print the second object, text array, square bracket 2, which you can see is Linda, and that's that. And then it goes through 3, and the third object is Tina, and then the fourth object is Louise. All right, so do you see kind of the mechanics of how these loops are working and how they interact with different elements, and how you can pull different elements from arrays that way if you know the right number? Okay, so let's do it again. It doesn't have to be a y, like I said. I could have replaced this with an I, which is what I usually do. So let's move on. So, okay, what if you want to do this and you've got a data frame, and it's not an array this time? So you've got rows and columns. So let's create a test data frame, df x equals a, b, c, and d. And this time I'm going to add an extra column that's called y, and I'm just going to leave it blank with na. So it'll look like this. Very simple. Okay, so what if I wanted to create a loop that maybe I'm querying something or doing some math that is pretty complicated, and then I need to, sub in to the specific cell for every row at the y and change it. So the way to do that is first you need to figure out how many objects are there. So technically how many rows are in this data frame. So instead of using length, you can use the function nrow. And then nrow around the data frame object name will give you 4. So now when we create a loop, we can do for I in 1 through nrow df, so 1 through 4. And then I want to say df $y for, this is the specific data frame, this is the column that I want you to focus on, and I want you to pull out the I incident of it. So technically for each row, for each cycle, it's going to be 1, 2, 3, 4, right? So I want to be like the first element of in dfy, which is first right now na, I want you to replace it with I, right? Which is the row. I'm sorry, which is the loop that it's on. And then print out what the data frame looks like. So it looks like this. The first loop, it'll go through the first one, and it'll be like, okay, I'm going to put in within dfy in the first element, I'm going to put in the I. And then I'm going to go through the loop again. And then, because I is already there, the y from dfy1, and now I'm moving on to dfy in the brackets 2. And I'm going to put in 2 because that is the loop number I'm on. And you can see the NAs are slowly filling in with every loop. And so the third loop, it fills in 3 here. And then the final loop, it fills in the last one. So you can see how it's changing the data frame with every loop. All right, so next thing I want to talk about is if-else statements. Also very important when you're dealing with programming in R. And you've kind of used this already when you've used case when. But this is kind of like the base R version, which is very powerful. So pretty much the way the structure works is you have to do an if, you have to type out if, and then in parentheses, you have to give it some sort of logical test. If this is greater than that, or if this equals that, or if this doesn't equal that, and then you have to do the consequence, which is put in the squiggle brackets. And so you just say, if it passes this test, then do this, execute this code. And you can then stack many different like tests, right? So if A is greater than B, then do this. If else if. So it's like if it doesn't pass this first test, then do else if. Else if B is greater than C, then do this instead. And then finally, and so you can do a bunch of else ifs on top of each other. And then finally, like the last one is like else if none of these tests were passed, then execute this last bit of code. Okay, so that's pretty much the basics of that. So this is how it would look like if I was doing a loop. So I'm nesting this if-else statement in a loop. So I'm going for I in 1 through 10. I'm saying if I is less than or equal to 5, then I want you to print out in a string combined format, like whatever the number is less than or equal to 5. Or if, and then else if I equals 6 exactly, then print out I is equal to 6, whatever the I is, probably 6. And then finally, the last one is like, unless, if none of those match, then just say, then we can assume that it's greater than or equal to 7, because it doesn't match those other ones. All right, so this is how it looks. So this is outputting the results from every loop. 1 is less than or equal to 5, and that matches up. 6 is equal to 6, and then everything after that is greater than or equal to 7. All right, pretty simple, right? Oh, it's a little complicated, but the more you do it, the more you get used to it. Okay, so the reason I wanted to show you how to do that is because sometimes when you're working with data, you're going to need to know how to append data, and if-else statements are a pretty efficient way to do that. There are probably better ways to do this, but this is the way I do it. And let's say you've got a data frame, you've got 2 columns, you've got a column full of numbers and a column full of letters. Okay, so this is what it looks like, a test data frame. Now, if I wanted to create a new text array, and I wanted to create a data frame, and I wanted to be like, okay, I want you to loop through and add the person's name in a column for each one, and then I want you to stack those data frames on top of each other and make a tidy table. Okay, this is what it would look like. Okay, so right now, if I went through the length of the array, Bob through Louise, and then I want to say, okay, I want to create a new data frame, take the data frame that I created, and then I want you to add and mutate to add employee equals text array I, because text array I is what, Bob, Linda, Tina, Louise, and then print out the df, it would look like this. So it's got the data frame, and then it adds Bob. Takes the data frame, adds Linda, takes the data frame, adds Tina, and so on. Okay, but finally, if I want to do that, the last data frame when I print it out is actually just the final loop. It's just Louise. It does not preserve all the other employee data frames. That's not what we wanted. We wanted to add them on top of each other to make a long data frame. So the way we do that in an using if and else is take the data frame, same code as before, take the text array, but this time we add an if-else statement. So if I equals 1, if it's the first loop, then go ahead and take the data frame that we created and save it as a new data frame object called big.df. And then, after every loop after that, if I is not 1, then we can assume it's the next step in the loop. And so then all we need to do is rbind big.df because it's saved in the first loop, and then we append the new data frame to it using rbind. And so it looks like this. It'll loop 1 through, just to print out 1 through 4, to see like we did it successfully. And then the big data frame that we print out looks like this. Instead of 4 rows each, it's got 16 rows. This is the new data frame, and it's one big, tidy data set. Very useful. Okay, so next thing I want to talk about is an even more advanced topic, and that is parallel processing. Okay, and that is, the idea is all these tasks that we do when we're working with loops, it won't stop until, a new task won't stop until the previous one is done. So this is called serialized processing. It goes one, then the other, then the other, then the other, which is usually fine. But sometimes you have to deal with really large tasks, really large data, and it's more efficient, especially if you're a reporter on deadline, to take those tasks and kind of split them up. And this is what you would, and take the CPUs on your computer, because there's a lot of cores now, and they're more advanced computers. And every one of those cores can take on a task and do them at the same time in parallel. So instead of doing things serial, it can be like, okay, I'm going to split them up and do them all at once. All right. So imagine like you're in a newsroom and you've got a team full of interns who can go and fill in a big database and spreadsheet and clean up data for you. So it's that same concept, but on your computer. So we're going to use a package called doParallel, and just follow these instructions. You can install the package called doParallel, add the library doParallel, and one of the functions that you can see how many cores there have is use detect cores. Okay, and in this particular computer, it's pretty new, I've got 10 cores, so I can do 10 tasks. I'm not going to use 10 tasks because sometimes I want to use some of these cores to do my other stuff. So first you need to tell it how many cores you want to use, and I'm going to say, you know what, I'm going to use register doParallel cores equals 4. Just use 4. And then I'm going to start my process over again. This is how you would do it in a loop. This is our former loop code. Now if we want to do this in parallel, you just need to adjust the code. Okay, so this is what it looks like, right? Now, to do the parallel version, you can see it's slightly different. We don't need the if-else statement anymore because it is now part of the function. And the function we're using is something called for each. Instead of for I in, it's for each. And the format looks like I equals 1 through length array, just like 1 through length text array. So it's slightly different. And then this time we pass it the function rbind, because that's technically what we want to do after every loop. And then do par within these parentheses signs. And then of course the squiggly brackets. And then we don't need to save it as an object. We just say, we start out with the df, and we tell it what we wanted to do, and it adds the column of the employee name for each version. So that is it. It simplifies it, and it makes it faster. And let me show you how fast. So yeah, pretty much the same output. Okay, so this is what it looks like. If within every loop, after every loop that I made the system sleep for about 5 seconds, and we use that function called sys.sleep. So, because let's say we're scraping a website, we want to put in a timer in between every scrape so we don't screw things up. We don't, settle the alarms. Or like I'm just putting system sleep in here because sometimes it does take a long time to wrangle a lot of data at that much. Maybe you're geocoding, for example. All right, so every loop has to wait 5 seconds. If I did that with parallel, everyone sleeps at the same time. So you can see that the elapsed time goes from 20 seconds for 4 rows to 5 seconds for all of them at the same time. And I'm testing that by wrapping all my code in this function called system.time. And that pretty much is kind of just a way to check if your code is more efficient, So you can see 4 times the speed. Very useful if you are on deadline. All right, got some weird code here, but okay, so this is what I want to show you now. For you to execute these exercises for this particular section is a little bit different from what you're doing normally. So I want you to run the same exercises through the browser, but there's going to be an additional step, and that is using this code right here. Install package, and then use this use course. What this is doing is I'm making you install this custom package that will allow you to pull code and data from a GitHub repo. And so it's nice and seamless the way it is. So let me switch over to RStudio. All right, I'm going to start copying and pasting some code over. So first I'm going to install the package, use this, and then I'm going to call it using the use this : and then one function, which is use course. And now I'm giving you code that will allow you to download the files from this repo and install it onto your computer. And then it'll say do you want to download this to your desktop? You can change folders if you want, but for now, I'm just going to say yes. Downloading, and then it's going to say, do you want me to delete this? And I said, sure. The zip code, the zip file, you don't need it anymore. And now it will pop up a new window, and you can't really see it, but it's opening up another R, and it'll have all the files there. Okay, and let me see if I can pause that real quick and see if I can switch it. Okay, so this is now what should pop up on your RStudio, another RStudio instance where this shows up, and you've got a folder of data and a few other files that may or may not be there by the time you download this. So what I want you to do for the rest of this is go up here, onto New File, click on RScript, and this is where you can start, and we'll save this as, we'll bring in a package, library, tidyverse, save this as script.r, and now it's there. Okay, and this will be useful for you, and it's a nice way to transition you from the browser to RStudio and working with scripts and through the console in here if you haven't done so already. So, great job on getting through this so far. I want you to go and continue this and keep working on your exercises so it really sinks in what you're working with, and then I'll see you for part 2.